Hey Chemistry, Mrs. KJ here, going over part 4 of the Unit 5 lab. So this time we're going to do it a little bit backwards. We have these chemicals that we need to do reactions, and we need to predict whether or not they're going to react. And then we need to go down here and write our balanced equations. And so we're going to actually start with this because it will save us time in the long run. All right, so we have NaCl plus CuSO4. And it says right here, for these, the charge of copper is +2. So that one I gave you. And sulfate is on our list of polyatomic ions. And so we know that that one has a charge of -2. And now we have to look at our periodic table for the charges of sodium and chlorine. All right, so here's sodium. It's in group 1, so it has 1 valence electron. So it's going to lose 1 electron. It has less of those negative bad electrons. Now again, they're not bad. We just think of them that way because they're negative. So we have less negatives, so we're going to have a positive 1 charge. So sodium, we're going to write +1. And then we'll go over here and find chlorine. Chlorine is a halogen. It's in group 7. It has 7 valence electrons. It's going to gain 1 electron, so it's going to have a -1 charge. And so we'll put that charge up there. And now let's make our products. So which one is the Na going to go with? Well, it's already with the chlorine, so it's not going to be with the chlorine on this side. Is it going to go with the copper or the sulfate? Well, it's +1. So positives are attracted to negatives, so it's going to go to the sulfate. All right, and then let's go ahead and make the formula. So this 2 would go right down here and tell us that we have Na2. And this 1 would go right down here, but do we have to write it? Nah, because it's a 1. We don't have to write it. So that formula would be Na2SO4. All right, so now we have our next compound, and we have Cu, copper, and Cl, chlorine left. Which one do I have to write first? I have to write the Cu first because it is positive. And we're going to bond it to the chlorine. So this 2 goes down here, this 1 goes down here. So what number is going down there? A 2. And we'll get rid of our charges. A 1 goes down right here, but we don't need it. And now we'll get rid of all these charges everywhere because we only wrote them in to help us create our new compounds. And now we can balance it. So this one says I have 2 copies of the NaCl. I have 2 Nas on this side, 2 Cls on this side. I have 1 copper on this side, 1 copper on this side, 1 SO4 on this side, 1 SO4 on that side. I'm balanced. I could also say I have 1 S on this side, 1 S on that side, 4 oxygens on that side, and 4 oxygen on my reactant side. But I just said SO4 because it's a polyatomic ion. Either way, it doesn't matter. I have the same number of every element on both sides, so it's done. Woohoo! All right, so let's do our next one. Our next one, actually, no, let's break it up. Let's break it up. So let's do this reaction. Let's put the sodium chloride together and the SO4, and we're going to predict if it makes a precipitate. So we have NaSO4. All right, NaSO4. So here's SO4, and we have to find Na. So here's NaSO4. Is this one going to be a precipitate? Is it going to be a chunky solid? Well, it's soluble. That means it's going to dissolve. So chunky solid? Nope. All right, and then our other one is copper with chlorine, copper chloride, CuCl. So let's look up here. Here's Cl, and we need to find it with copper. All right, right here. Is it going to be a precipitate? Nope. So we can put that in our prediction. Do you expect to see a precipitate? No. Both products, or both the chemicals that we are producing, should be soluble. Or in other words, they should dissolve. So let's go ahead and let's do that. We need copper sulfate and table salt. All right, so I need table salt. Come here. 10 of that, so that was my sodium chloride. And then we need some copper sulfate. Come here. Uh-oh, I did something wrong, didn't I? I better reread my directions. Let's see. Ooh, 5 drops of solution 1 and 2 drops of solution 2. Oops. Let's try that again. All right. Now I could say I did that on purpose to remind us to read directions, but I didn't. I was just thinking I knew it. So 1, 2, 3, 4, 5, and 2 drops of copper sulfate. Now, obviously, in an online lab, it doesn't matter that I screwed up, but in real life, you have to be very, very careful of chemical reactions because you could create something poisonous or not good at all. Whoa! Did that have a chemical reaction? Did you see that? Did you see that? Let me do it again. That happened really fast. Here, we'll put it over here. Man, it's just bouncing all over. Sorry about that. All right, so we have our light blue and 2 drops of copper sulfate. And so, wow. Okay, so kind of 2 steps. First of all, it turned what? Dark blue, and then it turned white. So was that a chemical reaction? Oh yeah, most definitely. So turned dark blue for about a second, then turned white and stayed white. So chemical reaction? Yes. All right, so let's go ahead and do the next one. Let's do sodium hydroxide with copper sulfate. All right, sodium. Oh, sodium. Actually, let's do these charges first. So copper, we know is +2. Sulfate, we know is -2. Sodium, we just did up there. Sodium is +1 because it's in group 1. Hydroxide is a polyatomic ion, so you have to look at that list, and it's -1. All right, so who is the sodium going to pair up with on the product side? It's going to pair up with the sulfate. Why? Because the sodium is positive, the sulfate is negative. All right, so again, what's our subscript? What little number is going to go right down here? This 2 means that there needs to be a 2 down there for a subscript. And look, we did it right up here. All right. Then we are going to have our next one. We have the OH and the Cu. Which one do we have to write first? The Cu. And why? Why do I have to write it first? Because it's positive. Are you sure? I'm positive. Ha 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 ha. Okay. So this one goes down here, and this 2 goes down here. But be careful. Because if I just put a 2 down here, if I get rid of everything else, now it says I have 2 H's. But how many oxygens do I have? I have 1. And over here, we realized that OH was a polyatomic ion family. And in chemistry, we are not home wreckers. You can't split up a family. So what am I going to have to put around my family to show there's 2 copies of that family? Yeah, put some parentheses around there. Yeah, so now I have 2 copies of the OH. So I'm going to show you the difference. So CuO, oops, H with another OH, I could write like that, versus CuO dash H dash H. Okay, so if there's no parentheses, if it's this, then that's that one down there. But I need 2 copies of the OH, and so that is why we have parentheses. All right. Okay, so now let's balance our chemical equation. All right, so I want to draw a line and split up my product and reactant side. And let's get rid of all these charges because I just put those on there to help make our products. And now I need to go through the list. So on the left-hand side, on the reactant side, how many NAs? 1. On the product side, how many NAs? 2. On the reactant side, how many oxygens? 1. What about on the product side? Oh. Back up, Mrs. KJ. 1 here plus 4 there is how many? 5. All right. On the product side, I have 4 oxygens here plus 2 oxygens there. So how many oxygens? 6. H is on the reactant side, just the 1. H is on the product side, 2, because I have to distribute this 2. And sulfurs on the reactant side, 1. Sulfurs on the product side, 1. Okay, when balancing chemical equations, I like to save the oxygen and hydrogen for last because, like I've said before, sometimes they just kind of magically work out. So, if I have 2 sodiums on this side, and if I want 2 sodiums on this side, and I have 2 on this side, what number do I have to put right there? 2. So now I have 2 sodiums, but it distributes. So how many oxygens? Well, I have 2 plus 4 gives me how many total? 6. I don't care that I had 5 before. I only want to know how many I have right now. So I have 2 plus 4 gives me 6. How many hydrogens? Distribute that 2. That gives me 2. And 2 sodiums. All right. Hey, check it out. Is it balanced? Yeah, it is. Everything is equal on both sides, which satisfies the law of conservation of mass, saying that the amount you start with, even if it's in a different place, has to be the same as the amount you end with. All right, so let's do this reaction. I have sodium sulfate. So let's look up here and see if it's going to make a precipitate. So sodium sulfate. Is it going to make a precipitate? Nope, it's soluble. That means it can dissolve. And what else are we making? We're making copper hydroxide. All right, so hydroxide is right here, and let's go all the way over to copper. Way over here. Is it going to make a precipitate? Well, it's insoluble. That means it will not dissolve. So yes, it should make a precipitate. So we're going to write that here. We said that this one, let's copy it. So copper hydroxide should make a precipitate, but NaSO4, got my 2, should not. So in other words, I should just have 1 chunky solid. So let's try it. All right, so let's grab 5 drops of this. And we're putting it with 2 drops of copper sulfate. And now if we wait a little bit, it's light blue, and so we'll wait and see. Oh, we definitely have a precipitate. And what color would you say the precipitate is? I would say it's like a dark blue, and the liquid is light blue. So we'll write that on here. So made a dark blue precipitate. Was it a chemical reaction? Yes, it was. All right, and we'll go to the next video now to finish this up.